Across the cosmos, astronomers keep finding worlds that appear to break the laws of nature. These are not simply unusual planets, they exist in environments where physics predicts total destruction. Some orbit so close to their stars they should have vaporized billions of years ago, while others are colder than interstellar space itself. Each discovery forces scientists to question assumptions about gravity, heat, and matter. What if our understanding of planets is only a small fraction of reality? One of the strangest discoveries is the class of ultra-hot Jupiters. These gas giants circle their stars in just a few hours. Their atmospheres reach temperatures hotter than molten rock, yet they remain intact. Powerful stellar radiation should strip them away completely, but their gravity somehow holds the gas together. Even more shocking, winds on these planets can reach thousands of kilometers per hour, redistributing heat across hemispheres and preventing atmospheric collapse. Then there are rogue planets, entire worlds drifting through space with no star at all. Without sunlight, temperatures should fall near absolute zero, freezing every molecule solid. Yet some still show atmospheric activity and internal heat. Scientists believe radioactive decay and pressure inside their cores create geothermal warmth, forming underground oceans. These lonely planets wander the galaxy like cosmic ghosts, proving stars are not required for planetary complexity. Another impossible place exists around neutron stars. These stellar corpses crush matter so tightly that a teaspoon would weigh billions of tons. Yet astronomers detected planets orbiting them. When the original star exploded as a supernova, everything nearby should have been obliterated. Somehow debris reassembled into new worlds. They now orbit in intense radiation fields that would instantly sterilize any known life, making them among the most hostile environments imaginable. Carbon planets may also exist, worlds where diamond and graphite replace rock and sand. Formed in systems rich in carbon but poor in oxygen, their mountains could be crystalline structures harder than steel. Lava there might be liquid carbon compounds rather than molten stone. These planets challenge our Earth-based expectations because geology itself becomes alien. Entire landscapes could sparkle under starlight like a cosmic jewel. Super-Earths present another paradox. Many are several times more massive than our planet, yet their atmospheres remain thin instead of crushingly dense. According to models, gravity should trap massive envelopes of gas, turning them into mini-Neptunes. But observations reveal rocky surfaces and weather patterns instead. Scientists suspect a known atmospheric escape processes or magnetic interactions stripping gases away, mechanisms not yet fully understood. In some systems, planets orbit binary stars in chaotic patterns, instead of stable circular paths. They weave complex gravitational dances between two suns. Simulations predicted such orbits would destabilize quickly, ejecting planets into deep space. Yet many remain stable for billions of years. Their climates would experience multiple sunrises and shifting seasons unlike anything on Earth, showing orbital stability is more flexible than once believed. Water worlds push impossibility even further. Some planets may be covered by oceans hundreds of kilometers deep. Pressure at the bottom would form exotic ice phases hotter than boiling water. Above lies a global sea with no continents at all. Without land, weather cycles operate differently, and chemistry may evolve in unfamiliar ways. These oceanic giants redefine what a habitable environment could look like. There are planets with density lower than foam, known as superpuffs. They are the size of Jupiter but lighter than Saturn. Their atmospheres extend enormous distances into space like giant clouds. Stellar winds should blow them apart, yet they persist. Their gravity barely holds particles together, making them appear more like inflated balloons than solid worlds, challenging ideas about planetary formation. Magnetar planets may be the most terrifying, orbiting stars with magnetic fields trillions of times stronger than Earth's. Atoms themselves become distorted. Chemistry changes because electron paths warp under magnetic pressure. Any material there would behave differently from known matter. These planets exist where physical constants almost feel rewritten, revealing how extreme environments reshape reality. Some worlds rain molten metal. On certain exoplanets, temperatures are so high that iron vaporizes into the atmosphere and later condenses into droplets. Imagine clouds forming from metal vapor and storms pouring liquid iron onto glowing landscapes. These conditions exist naturally, not in theory, proving planetary weather can be far stranger than anything in our solar system. Tidally locked planets add another mystery. One side permanently faces the star while the other remains in eternal darkness. Temperatures differ by hundreds of degrees, yet atmospheric circulation distributes heat enough to prevent atmospheric collapse. A thin ring between night and day may host stable climates. Entire ecosystems could theoretically exist only along this narrow twilight boundary. Even more bizarre are planets forming inside stellar disks of white dwarfs. After a star dies, its debris spreads into a disk of metal-rich material. Over time, gravity shapes this rubble into new worlds. These second-generation planets are born from stellar remains, composed of heavy elements rarely found in young planetary systems. There may also be dark matter-influenced structures. While not fully confirmed, some models suggest regions where gravity behaves unusually, allowing matter to clump differently. If planets form there, their density and motion would not match classical predictions. Observations of unexpected orbital speeds hint such environments might exist somewhere in the galaxy. Perhaps the strangest worlds are those older than our galaxy's spiral arms. Ancient planets formed when heavy elements were scarce. According to theory, rocky planets should not exist in such early eras, yet they do. Their presence means planet formation began far earlier than expected, rewriting the timeline of cosmic evolution. Every impossible world teaches the same lesson. The universe is not obligated to follow human expectations. Physics remains consistent, but our understanding of it is incomplete. Each discovery expands reality beyond imagination, showing that what seems impossible today may simply be undiscovered science tomorrow. The cosmos is not strange, it is vast, and we are only beginning to understand it.